Hello, everybody. I've been spending most of the night and much of yesterday talking about Mac files because of this problem with the way the Mac and the Windows don't agree on how we should end lines. I think the next time when I want an input file, I'm going to send you the code to create it. And I think that may work, but we'll see. Now, today, what I want to do is I want to give another example using the random and the fors, and it'll lead towards other things. But let's see, give you a problem, and we'll see how you would do it. I want to make sure you understand the for loops and you understand placement of things and looping in period. So here's my problem. How good is the random number generator? Well, one approach is to use it to do something where I know what the answer should be, know roughly what the right answers are, and see if I get close, get the correct results. For example, suppose I toss a four-sided die 12,000 times. Now, four-sided dies would be called tetrahedrons, and I think they are, or pyramids, and they actually exist, I think. So, if I were to toss it 4,000 times, I expect approximately 3,000 ones, 3,000 twos, 3,000 threes, and 3,000 fours. Notice I did not say exactly 3,000, 3,000, 3,000, 3,000. If I got exactly the 4 at 3,000, it would either be a fluke or somebody's been playing with my dice, because it's not going to come out exact. The probability is that I'll be around 3,000. If I got 1,000, 7,000, and then 1,000 and whatever, I would worry about the random number generator. I'd like them to be close. And in fact, what I'm going to do is I want more data. So I'll repeat this trial of tossing 12,000 die, 12,000 times, a certain number of times, and look at the average. That way we really should be getting close to 3,000. So, this seems like a reasonable approach. People do this kind of thing to test how good a random number generator is. They do other things too. Look at, say, how often a 1 is followed by a 2, and how often a 1 is followed by a 3, to look at the pairwise probabilities. And you can want to check and see if they pass, if they're reasonable, because the random number generators are very important to many kinds of programs, not just games. Many other kinds of programs that want to model something in the world that is best modeled by a probability would use a random number generator. Now, I've already written this program, but before I write it, before I show it to you, I'm going to look at the algorithm again. So I'm going to try to create an algorithm. I like to make it fairly general, so I'm going to not insist that it be 12,000 times. Instead, I'm going to let the user pick how many times they want to toss the coin. And I'm not going to decide how many times I want to run trials, how many trials I want. I'm going to let the user decide that too. So basically, I'm going to input the number of trials, and the number of tosses in each trial. I'm going to insist they be the same for each trial, because otherwise I'd have to do a little more work and I don't feel like it. This will work better. So once I get that in, now here's where you really have to be careful. I need two for loops. I need a for loop for each trial, and then within that for loop, I need a for loop for each toss. They can't have the same variable to count. They have the one's inside the other. I can't let them be different. They have to be different variables. Also, the one with the toss has to fit completely within the one with the trial. It can't stop after the one with the trial because it's inside. It's part of what I'm repeating. And I have to be careful of how I set up things. So within each trial, I want to set the counts of each type of toss to 0. Now, this is where some people would be making mistakes. I just had one, in fact. You have to reset the counts to 0 each time because you want the count for that trial. Now, it might be that you don't feel like you need it in some cases, but often this is the way you want to do it. Now, for each toss, I am going to toss the die and add to the right count. And I've left that purposely vague. I'll fill it in. Now, after I get each toss, I want an overall count. So I'm going to set the total counts for all trials to 0. Again, notice I'm doing it outside the trial loop because I want to do it once and only once. I don't want to repeat it. But now, after I get the counts for this particular set, after I finish all the tosses, that's where I add the counts to the total counts. And I probably want to do also, before I add that, I probably want to print, wrong way, I want to output the totals. Notice again, I did not do it for each toss because it depends on a trial. For each trial, I want the totals. Now I add the counts. I'm not printing them out right now because I'm still within the trials. Now I have to go, when I finish all the trials, now I will output the total counts. I guess I'll call them the total counts. You have to think these things out. I'm having a lot of people who just say, well, can I put it here or can I put it there? That's not the right question. The question is, where do you need it for your algorithm? I put the total counts, if you look, outside before I did anything. And I only did it once. But for each trial, I'm starting over. So I reset all my counts to 0. And for each toss, I just added to the counts. I didn't bother printing them out until I finished that trial. So that is more or less the algorithm I want to use. And I more or less did it. I think it'd be faster right now if I show it to you rather than just bring it all out. It's a little long, so that's why. I had enough include files for anybody. 5 of them at this point. All that you've seen, about the only thing missing is math.h. But I put in the using namespace standard. I have to, or I won't be able to do everything. I'm getting it to tell me that cout is red. I have no idea why, because it works. I don't know why it's putting the underline on that. Now, notice what I did. I initialized 4 counters. And then I initialized, and then I declared 4 counters. I declared 4 total counters and initialized them to 0. The danger for many people is that they would have initialized these counters in that first line to 0. And that would only have done it once. I can initialize the total counters to 0 because my algorithm only does that once. So it's no problem if I do it where I declare them. But you don't want to do it the other way. I guess technically you could do int the counts here and set them to 0. But I don't see any reason for that. It worked out this way. So I asked the user, how many trials do you want? I asked the user how many tosses they wanted. I reset sran to get myself started. Then I wanted pretty output, so you'll see my set W's. And for the first time, I used not integers on the set W's, but words. So let's see if they line up properly. Then I've got my trials. I set my 4 counts. Now I've got my tosses. I toss. Choose which one to add to. Print out the totals for this trial. Again in the set W's. Add those counts to the total counts. Now that trial is finished. So that ends that trial. And now, in fact, I think I'm going to put a little note there. Ends one trial. And now I'm going to print out the averages. And at first I didn't put in this fixed, and they came out wrong. Well, they came out, the answers may have been okay, but they certainly didn't look good. So besides the set precision, I needed the fixed. And I chose 1 decimal digit. And notice I did the arithmetic in here. So this is how many I got in each trial on average. And that was it. So let's see if the program runs. So here we go. Well, let's see. Let's try 20 trials. And let's toss 16,000 times. I don't think I want 160,000. I think 16,000 will do. Now I should get 4,000 of each, roughly. Well, those look pretty good. I don't see anything below 3,900 or above, much above 4,100. And the averages are pretty good. I have a 4,000.1, a 3,999.4, 4013.7, and 3986.8. In fact, those almost are too good. But that would be expected because I have a lot of data there. Also, notice that thing just ran 320,000 rows of the die. If I had to do that, I'd be doing it for the rest of known time, I think. So that's where the machine has a great advantage on us. In fact, I'm going to run it with a bigger number. I'm going to have 100 trials, and I'm going to run 400,000 each time. Should get averages about 100,000. I think I came pretty close. So it looks like the random number generator isn't doing badly. Now, I did this program because I want you to realize that when you're looking at loops, your question is, what am I repeating? That determines where you put things for the loops. And I wanted to do another example of a loop within a loop, and to show you for sure that they have to have different variables counting them. And the second one is completely within the first one. It also helps that we have a little more set W. And I want you to notice these 4 lines are identical except for 1 character. If you look at these, they're identical except for 1 character. These are identical except for 1 character. We're going to fix that. Most of you who have enough Python understand what I'm going to, arrays or vectors, or I guess you would call them lists in Python. But that's coming soon, no later than next week. So that's where I am right now. Let me print this program into this file, which I'm going to post. And keep up the good work. I'm seeing many of you doing well. My biggest problem at this point has been the problem with this ending in the Mac files. I think it's solvable. I've gotten 3 people through it so far, and I think we can manage to get others through it if you can't do it on your own. So that's where we are. I'll see you later. I will probably have another homework for you no later than tomorrow.